Okay, so I hope you guys were able to factorize all of these numbers into their prime factorizations. So without further ado, let's get into applying our divisibility rules and yeah, to try to factorize these. So first off, we're going to look at the first number, 96. I'll show you guys a way you guys can easily factorize things. Just makes life easier. It's called a factoring tree. Some of you might have come across this before, but when you're starting to first factorize things, it's a good method to go with because you can keep track of how many factors you have. And so with the first one, what we're going to do is we're going to write 96 over here. So now we branch it out into two factors. And what I mean by two factors is you pick a prime number. So I picked 2, for example, because 96 is evidently divisible by 2 because its last digit, its units digit, is divisible by 2, based on our divisibility rule. So the other side will be 96 divided by 2. And if you divide 96 by 2, you should get 48. Okay, so the point is you keep splitting into 2 branches for each number as long as it's not a prime. So 2 is a prime, so we're going to underline it. And then 48 is not a prime, so you're going to split it again. And so 48 is evidently divisible by 2 as well, so you're going to split it into 2. And 24 is also divisible by 2, so you're going to split it. And it's 12. This is divisible by 2 again. So it is 12, 6. And so now it's 2 and 3. So both of these are prime. So now what you do is whatever is underlined, you go and circle those. And the product of these is your prime factorization. So it's 2 times 2 times, the product of these is equal to 96. So 2 times 2 times 2, and then 3. So the power, how it works is, it's the number of times a number occurs in this product. So it's 2 to the power 5 times 3 to the power 1. And that's our prime factorization for 96. Okay, so that's the process that you can follow when you start off with prime factorizations to try to go about factorizing things. So I'm going to leave this up here for at least doing the next example, and then after that I'll erase it because of lack of space. So 1001 now. So here it doesn't seem like we could really do 3, or let's test out numbers. So we're going to do 2. It doesn't end in an even digit, so it's not divisible by 2. It's not divisible by 2 to the power n either. It's not divisible by 5. So those are the first easy checks. We're going to do divisible by 3 next, because it's the next easier one, and the sum of the digits is 2. So that's not because 1 plus 0 plus 0 plus 1 is equal to 2, and 2 is not divisible by 3, so then that implies that it's not divisible by 3. 1001 is not divisible by 3. So now we can go to 11. That's the next one I would go to. And if I go to 11, I'm going to label it, right? A, B, A, B. So A's go first, so 0 plus 1, minus B's, so it's 1 plus 0. And then you go 0. And 0 is divisible by 11. Sorry, 11 divides 0. Check mark. So 1001 is divisible by 11. So if you divide by 11, you get a certain number on the other side. So in fact, when you divide, you get 91 on this side. And when you divide 90, so 91 is here now. So now let's try to go about doing 91. So I'm going to try out, we already tried out 11. I'm going to try out 7 and see if we can use our rule. So 9, and then you cut off 1. So 1 times 2 is 2. 9 minus 2 is 7. 7 is divisible by 7. So this is divisible by 7. So this is prime, and the other side is 13. So we circle this, and we get that this is equal to 7 times 11 times 13. And all to the power 1. So that's the way you would write your prime factorization. Remember to kind of have the exponents there in your prime factorization because that's how you uniquely write it. Okay, so I'm going to erase this portion over here so that we have space enough to do the next questions. Oops. Here, it's fine. Okay. For 972, so we have 972. It's divisible by 2. So we're going to divide 972 by 2. So you get 4, 8, 1, 17, 8, 16, 1, 12, 486 on this side. 486 is also divisible by 2, right? Because it ends in a 6, and that's even. So we're going to 486 divided by 2. And that's going to be 243. Okay, so now 243 is the dead end in terms of two even numbers. So we're going to try other numbers. So again, we try 5. It doesn't work because it doesn't end in a 5 or a 0. We can try 3. And if we try 3, what we're going to do is sum, right? So 2 plus 4 plus 3, that's equal to 9. It's actually divisible by 9. That's something we know. But, we're trying to prime factorize, and we want to get a prime on one side and something else on the other side. If you divide by 3, you get 81. So we know that it's divisible by 9, so we could divide by, but also you might know on the top of your head that 81 is equal to 9 times 9. So you do 3, you get 27, you do 3 again, you get 9, and you get 2 3s. So these are your numbers. And so you get 2 times 2 times 3 times 3 times 3 times 3 times 3. And that's equal to 2 to the power 2 times 3 to the power 5. So that's our prime factorization. For 126, so 126, again, you can divide by 2. So if you divide by 2, you get 63. 63, let's try out something. Let's try out our 7 divisibility rule in it, because just, to test it out. So what we're going to do is we have 6 and 3. We're going to truncate it, so we need to cut it off. So 6 and a 3 over here. 6 minus 2 times 3 is equal to 0, and 7 divides 0. So this is divisible by 7. So then now you have 9, and 9 is 3 and 3. So these are our prime factors. So you get 2 times 3 times 3 times 7. And if you write it out as prime factorization, you get 2 to the power 1 times 3 to the power 2 times 7 to the power 1. Okay. Now let's try, so I'm going to clear up the board a little bit. But now let's try some other examples. We're going to try 828 and 1749. And so those are our last 2 examples for practicing prime factorization. And then we shall go into our proper examples. 828, so that would be so 2, right? And on this side, if you divide by 828, then you 828 by 2, then you get 414. So now what we're going to do is test. So this is also divisible by 2, so you can divide again. And when you divide, you get, so it's 200 plus 7. So it should be 207. Yeah. Now you're at a dead end. You can't do dividing by 2 anymore. So we're going to do divisible by 3 rule, because that's our next bet, since it doesn't end in a 5 or a 0. So 2 plus 0 plus 7 is equal to 9. 9 is divisible by 3, so this number can be divided by 3. On the other side, we get 207 divided by 3. So that's 18 to 27, 69. 69. So 69 is divisible by, is it divisible by 3? Let's see, we can try again. 6 plus 9. Remember to keep trying a certain number until you're confident that it doesn't work anymore. So if we skipped over 3, we might be in trouble. So although we already divided by 3, we're going to try again. So it's 15. 15 is divisible by 3, so we're going to divide by 3. And on this side, we get 23. And 23 is prime itself, so we're going to circle it. So now we get that this is 2 times 2 times 3 times 3 times 23. And yeah, so and then now you just go 2 squared plus 3 times 3 squared times 23. That's your answer. Okay, and so our last one, the seemingly large number, but we shall break this down pretty quick. So I'm gonna clear this part of the board up, this question. And so 1749. So first things first, it's not even, so we can't use our 2. We can try 3 though, because it doesn't end in a 5 or a 0, so it's not divisible by 5. So let's try 3. So 1 plus 7 plus 4 plus 9. Well, that's 8 plus 4, so that's 12 plus 9, 21. 21 is divisible by 3, so you can divide by 3. And I'm going to divide by 3. And the reason these divisibility rules are important is because you don't go on doing long division for a bunch of different numbers. You could just cross it off and be like, okay, it's not going to divide. So I guess this is, what is it? 5, 15, 2, 24, 8, 3, 583. Now 583, let's try 3 again. 5 plus 8 plus 3 is equal to 16. So that's not divisible by 3. So after 3, next in line we have 11. So we're going to try 11. So 583, let's write it over here. So we're going to do A, B, A. So A group first, 5 plus 3 minus 8, B group, which is equal to 0. 0 is evidently divisible by 11. So 11 is one of the prime factors. And then the other one, when you divide it, is 53. And 53 is also prime. So this one was relatively straightforward based on some simple division. So you get 11 times 3 times 11 times 53. And if you write in prime factorization, it's 3 to the power 1 times 11 to the power 1 times 53 to the power 1. And okay. So now let's go to our examples. Those were finding prime factorization. It was a good exercise, and we were able to, do the tree method, and that was convenient. So here's a example. The number 64 has a property that it is divisible by its units digit. How many whole numbers between 10 and 50 have this property? So I'll give you some time to work on it, and then we'll come back and discuss the problem.